Alright, this is our third quiz of the unit, and I just want to review it with you, see if there's any common questions or anything that you need clarifying on. So, this first one, I think the most common error was not reading the question. So it says, this point is the midpoint, so I'm going to write it here to help hold that, of this point, and one we don't know. Okay, maybe that's enough and you can see where you made the error. Now let me show the most common way that students like to solve this is by a pattern. You can also solve it every time by algebra. So ask me if you'd rather do it that way. Let's look for a pattern in the x's. -5 to -4 is +1. So let's use the same pattern to get the x here. Okay, label that. So -4 + 1 equals -3. So that's what goes in this box. Alright, and let's find the y pattern now. Right here, -7 to -1.5, and that's actually going to be adding 5.5. Okay, so when I add 5.5 to -1.5, I get 4. So again, common mistakes: 1, not figuring out which one is actually the midpoint; 2, not finding out the pattern correctly; or 3, not adding and subtracting correctly. Alright, let's look at the next one. This one asks you to find length. That was actually the most common mistake, was not reading the question. It says find the length of the radius. I can see here, if I draw on this triangle, that this part right there is the radius. This is 1 wide, 1, 2, 3, 4, 5 wide. So let's use Pythagoras. This is the Pythagorean theorem, c being the radius, what we want to find. So that's what we want to figure out. So let's plug in what we have. 1 squared plus 5 squared equals, we don't know, c squared. Alright, let's solve it. 1 squared is 1. 5 squared is 25. Alright, to solve this, I ran out of space, so let's add them together. We're not done yet, okay, because we have to actually figure out what c is by itself. So we're going to take the square root of 26. Now, the next most common mistake I saw was rounding. So, right here, 5.099, it rounds up, so that means this rounds up here, which means this rounds up to the next spot, so we should have c equals 5.1. Okay? So, most common mistake, rounding, 2 decimals, 9 would round the 9 up, you can't just cross it off. 3, right here, that's what we would need to use as the triangle for the legs to find the hypotenuse. Alright, equation. Let's just write the center. So this center of the triangle was at 1, -3, and we know the radius equals 5.10 from this problem. So let's solve it. X minus 1 squared would shift it back. Y plus 3 squared equals 5.10 squared. If that was a too fast review, make sure you ask me about that. Alright, we're doing the same thing here. Here's the center. We need to shift it back to 0 to write the radius, to get the radius correctly with the equation x minus 3 squared plus y plus 10 squared. Again, that would make this go to 0. That would make that go to 0 equals 40 squared. Alright, now to check a point. This is the x, this is the y. Let's plug it in. 36 minus 3 squared plus, let's put in the y. Alright, let's simplify. 30 squared plus 33 squared equals 40 squared. Okay. When I do this and I add it together in the calculator, I get 1989 equals 1600. That's not true. So, again, when you find and trying to figure out if it's inside or outside or actually exactly on the circle, you look here. And it's not exactly on because it's not equal. Okay, and that's what the equation tells us, is all the points that are equal exactly on the circle. So this right here is greater than, so it has to be outside. I would want an explanation that said, because it's greater than, in the math we know it must be outside the radius distance, so we couldn't catch the fish. Alright, those are all of our first big ideas before the constructions. Okay, so let's actually move on to a construction. Okay, so we have a triangle island. We want it to be equal distance to all the water. That tells me, since there's water on every side, that we're looking equal distance to the sides. Okay, I have three choices. I can either make the median, which would connect the midpoint to this across. That doesn't look like it'd be equal to the sides. Do the perpendicular bisector. That line definitely wouldn't be equal to the side, so the only thing I have left is angle bisector. Okay, so, to do the angle bisector, here, I would make this construction here. Okay. And, oh, sorry, I forgot a ruler. Okay, let's use this. Alright, so let's check here again. This line needs to be equal distance to the sides. Let's see. Sure enough, this line looks like it's equal distance to each of these two sides. Not enough to solve it. We have to repeat the same step from each side. I'm going to do 2 of the 3 to speed up the video, but okay, again, use my fake ruler here to connect the middle of the angle to the vertex here. Alright, so this line looks equal distance between these two. Let's see how good it is by just doing 2. Again, you should do all 3 of them. You'd actually need to find the line equal distance to both of those sides. Let's check. We know it hits the sides, so I can draw a circle on the inside hitting the sides. Let's see how this goes. Ooh, I'm a little off on that one. A little off on this one. Not surprising. Okay, so equal distance to side. In the explanation you say, I know I'm right because my circle hits all the sides equally, which means this house will be equal distance to all the water. Second part of the test. Again, the hardest part of this might be determining what the scenario says. So as we read the scenario, it says there are 3 stores. These are the 3 stores. Okay. Now, we know we can't use the one from last time because if I was to draw an angle bisector, there's no way that line would be equal distance to all 3 stores. The choice is if we look at these 2, let's start with them, and we want to find equal distance between just those 2 points, or those 2 stores, we would do the perpendicular bisector. So, right here, this line then is exactly equal between store Z and store X. Okay. And we see that it should be at 90 degrees as well. Looks slightly off. Okay, let's try the next one. Okay, so again, this perpendicular bisector line should be equal distance to both store Z and store Y. It should be at 90 degrees. Looks better right here. 90 degrees. That line is equal exactly between these 2. Alright, so any spots, oops, it's not crossing, so I'm going to extend that a little bit. Again, I would want you to also find the middle line between this. I guess I could actually do it here. So fast construction. Since I feel like my first one was off, let's take a look. Yep. Okay. Alright, when I look at that right now, I guess it's an example that I really need to do that first one over again because something happened because these 3 are not meeting. So let's look at that together right here. That looks right here. I must have let my paper slip. Let's redraw this line in. Okay, and sure enough, now it's perfect. Okay. Again, visually, as I mentioned, it looked a little off. I could see this is not 90 degrees. The new one I redrew is 90 degrees. Okay. Making sure that pencil doesn't move or any of these things. Let's check if this corrected line is right. Probably a lesson in being in a rush. Alright, goes through Y, goes through Z. It's perfect. Okay, right here, now this point is where I'd have to be able to be equal distance from each of the 3 stores. You could talk about the circle on the outside for your explanation. Alright, lastly the vocab that goes with all of this. Oh, Okay, now from getting the performance task. I can't really demo that for you. This should have been the centroid with the medians, and you should have been able to balance it. I think that pretty much everyone did, but talk to me if you're not sure about it. Circum center, what's special? It's equal distance to the points. Okay, and when it's equal distance to the points, to do that just like we did above, we would do the perpendicular bisectors. And how do we prove or write? Circle on the outside, because when it's on the outside, it hits all the points. All right, in center, opposite. In helps you remember equal distance to the sides. We would do the angle bisectors, like the problem on the front. And we prove or write by circle on the inside. Okay, as an in center, inside. Centroid, what's special? It's the balance point. Construction made, we're going to make the median. And you didn't see me do it on this quiz because it was a performance thing, but you'd find the middle and then you draw across to the vertex. And what's prove, you'd actually have to balance it. Which I know that's not very different, so I was not very picky about that. Alright, I do want to show the extra credit because there were some of you who had questions about it. Again, this is kind of really neat when we get to drafting and engineering. There are a lot of ways to do things without a ruler or any of the usual. So I'm going to draw a line. Okay, and I want to find 40 degrees. Now the thing is we have to put in, when I do this construction here with the perpendicular bisector, okay, I know if I do this construction, because it's equal distance from the 2 points and it's 90 degrees, that right there is going to be 90 degrees. I'm going to pay attention to this top angle. I know that I can actually cut angles in half. Cutting angles in half would be an angle bisector. We usually don't do it to find particular measures, but we can now that we prove that's 90, because we started with the perpendicular bisector. We can use the angle bisector to cut it in half. And here, now this line is 45 degrees. Alright, you have until Friday to retake this test, review it. These problems will be very, very similar to what's on the unit test.